Morning everyone, I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture, I'm going to explain about Huffman coding. In the last video, I explained about shannon coding. It is quietly similar to that of shannon coding. We'll discuss here. So the main principle of this Huffman coding is it also uses the same principle as shannon coding, that is assigning different number of binary digits to the messages according to the probabilities of occurrence. This coding method leads to the lowest possible value of L bar for a given message sequence M, resulting in a maximum of efficiency. Hence, it is called as the minimum redundancy code or the optimum code. The procedure for this Huffman coding is mainly where we'll be considering n messages which are arranged in an order of a decreasing probability. For example, if the messages M1 to M6, the messages M5, M6 have lowest probabilities and hence they are put at the bottom in the column of the stage. So in the step 2, the two messages of lowest probabilities are assigned binary 0 and 1. The two lowest probabilities in stage 1 are added. The result R1 is again arranged in the decreasing probabilities with the other messages, that is M1, M2, M3, M4 R1. If the result is lower than the other messages, otherwise this R1, M1, M2, M3, M4, if the result is greater than or equal to M1, then it will be R1. So the sum of probabilities in stage 1 is placed in stage 2. Remember that we have to maintain the decreasing order among the probabilities as explained previously. So this will be calling it as a reduction, where the number of symbols in the stage 2 will be reduced by 1, and this reduction continues in each stage. So now the last two probabilities of stage 2 are assigned 0, 1 and they are added. So the result R2 has to be rearranged with the other simple probabilities and placed in the stage 3. So here the procedure is repeated until we are left with the final list of source symbols of only two of which 0 and 1 are assigned. This results in a construction of tree known as a Huffman tree. Step 3. The code word calculation or encoding process begins at the last reductant stage to first reduction for each symbols. So this will be the formulas for Huffman coding. To find the average code word length, will be averaging the particular code word into the probability, code word length into the probabilities. Then in order to find the entropy of the source, we'll be considering the probabilities and taking the logarithm of that particular probability and we are averaging it. That is called as entropy. For the code efficiency, entropy will be defined as H here and the code word length is L. So for efficiency, we have to divide that entropy and length and we'll be getting a code efficiency. So this is the example of Huffman coding. We are considering the four probability symbols of 4 with the 4 probability. Then the symbol A, B, C, D will be having in 4. So first we are arranging it in the decreasing order of probability. So the probability here we have to assign it in the decreasing order. So 0.4 will be there. Then considering it 0.3, 0.2, 0.1, 0.1 and 0.2 is at the decreasing stage. So we have to add that particular symbol C and D. So we'll be getting 0.3. That 0.3 should be added to the topmost, that is after 0.4 that added 0.3 probability should be added, then again 0.3. So if we add that 0.3 and 0.3 will be having will be getting 0.6. So that 0.6 will go to the top, then 0.4 will come at the bottom. So the probability for that 0.6 is 0 and 0.4 will be 1. Likewise, we have to assign the probabilities of zeros and 1 and we have to find the average code word, then the entropy, then finally the process of efficiency. and will be we can able to calculate the redundancy also here. If we minus 1 with that efficiency, will be call it as a redundancy, that is 1 minus efficiency. So 1 minus the particular 98, 97, etc. That particular efficiency will be used and will get as a 96. That will be the redundancy there. So the main difference between the Huffman and the Shannon coding is Huffman will be having good efficiency when compared to Shannon coding, and it has high optimization when compared to low optimization. So it is based on the source simple probabilities. Here it is based on the cumulative probability distribution function. Drawback of Huffman code is it requires knowledge of the probabilistic model of the source, and the storaging requires here, which prevents the Huffman code from capturing the higher order relationship between the words. This is the assessment questions. Thank you.